We're now going to turn our attention to a more detailed overview of Spring WebFlux, which is the other variant of communication and threading and so on that's supported with Spring Boot 2.0. And we'll see that it's got some interesting characteristics that go well above and beyond what you get out of the box with Spring Web MVC. But as we'll see in the next lesson after this one, you can use these together in a very seamless way if you so choose. So here's Spring WebFlux. It's essentially a non-blocking web framework that leverages multiple cores more effectively and can also handle a large number of concurrent connections. And that is in distinction with Spring Web MVC, which is the earlier model that uses synchronous I/O, and there's pretty much a thread for every request, so it starts to run up against a wall very quickly. The requests that are sent using WebFlux are handled in an entirely asynchronous and lazy manner. And I'll talk more about what lazy means in this context when we get into the details a bit. So in this particular model, you could have a request to a list of flights from the database over the network might take a few seconds, but the threads servicing the requests and the responses don't block, number one. And we'll also see that there's some other cool things as we get a little further along. So one of the consequences of this is the fact that a smaller number of threads are typically needed as opposed to having a large number of threads, which is what you end up with Spring Web MVC, where you typically have a thread per request. So the basic model here is that the number of threads that you would have in some kind of thread pool, which is managed for you by Spring by default, would typically be related to the number of processor cores. Now, it's not always a one-to-one mapping, and the reason for that is that I/O-bound operations may need to be able to adaptively increase the number of threads. And there's a various number of means for doing that. With Project Reactor, there's a parallel threads pool, which knows how to grow the threads dynamically as things block. With RxJava, there's something similar called the I/O thread pool, which also has the ability to adaptively resize itself as the need arises. However, because of the fact that there's asynchrony going on here, there's often a need for some type of non-blocking back pressure. And the basic idea is you don't want to have a fast publisher overwhelming the resources of a slower subscriber. And there's various ways that are kind of baked and built into Project Reactor in order to be able to accommodate that particular need. And we'll talk about those probably in 2 weeks, I would think. Now, let's talk about how network communication works. This is actually quite different from how it works with Spring Web MVC, and it's one of the main benefits, as well as the fact that you don't need as many threads because the whole thing's asynchronous. So what you get if you choose to use them with WebFlux is you can use so-called Project Reactor types. Now, you can also use traditional types if you want to. You can use things like lists and maps, but what I would advise against it because of the limitations we talked about before, where everything has to be transmitted in one fell swoop. So you can see here that we're going to have the ability to pass around fluxes and monos. And as you can see here, you probably remember this before, that a mono is a sequence of 0 or 1 elements, and a flux is a sequence of 0 to n elements. And if you look at the particular example I have here, which is from the Flights Reactive Microservices app, you can see how we have methods like find departure dates that return a flux instead of a list, and likewise methods like get rate return a mono instead of an exchange rate directly. And we'll talk a little bit more maybe in the next lesson about why this is such a win. And there's also a nice set of operators that you can use that are aligned with all the Rx, Java, and Project Reactor operator vocabularies. This is part of something called Reactivex, which is a generic way of describing operations that are then implemented by different providers in different languages in different ways. Now, this is why using reactive flux types can be a big win. And you can take a look at the link at the bottom of the slide, which I'll post later for more details. But these reactive flux types can be streamed element by element. So you might request the airports, and then you would get a flux of airports. So if it takes a while to get the list back, you don't have to wait for everything to come back. The client can start to process the results right away. And maybe airports isn't the most exciting example, but like finding prices might be a better example because it might take a while to find all the prices, and you might want to be more responsive so the client can be throwing up some prices while the other prices are still arriving, thereby giving the user the illusion that the system is more responsive.
And it will even be better for real-time quotes or anything like that, where quotes are streamed in a real-time manner, I guess.
Yes, in fact, that's the next bullet here, which is the stream can be kept live by using Spring so-called server sent events. And you can take a look at this link down below for how this works, but this is exactly what we just talked about. It's a way for the server to keep the connection to the client open, and it'll basically just keep sending back the next elements, or the elements that show up in perpetuity until it explicitly decides to stop doing so. This is sort of a contrived example just for kicks, but you can see here that I created a get rates method that returns a flux of exchange rates, and I use the produces tag in the get mapping annotation. And what I say is produces media type text event stream value. Ignore the text part. What that basically says is that this will continually stream back the rates to the client, and as the exchange rates change, which they probably will over a period of time, then the client can automatically get those exchange rates with the freshest and most up-to-date version. The way to look at this is basically sort of a pub sub-like mechanism where clients can essentially subscribe without saying so by having this mechanism, and it basically lets the server just keep the connection live, and it'll send back the data as it arrives. So I think that's super cool and very powerful feature. And I'll probably create an example here at some point soon to show you how to do this, but it's a really neat example. So for things like stock prices, this would be ideal for that because they could go on forever, or Twitter feeds or whatever you're trying to keep live.
Doug, I have a question.
Yeah.
So do we have like any JavaScript client which can actually render this in the browser, like as the Flux is coming into the client?
Oh yeah, absolutely. Yes. The bulk of this stuff is really intended for browsers. I'm using it in this example for like an Android client, but you could do the same thing with browsers. Absolutely, yes. So one of the consequences of having this reactive mechanism with streaming the data element by element is that a reactive stack, in some circumstances, depending on the use case and various factors, can have better response time and can send back more requests per second than the more traditional Spring Web MVC approach, which is more synchronous. So the synchronous approach will use more resources in terms of threading, and you'll have to wait until everything comes back. With the reactive approach, you don't have to wait, and you use fewer threads. So it's generally a win.